textbook doesn't do a lot of examples where they don't give you a graph to begin with. Usually the textbook ones give you a graph and then you have to draw it. But you also need to know how to do stretches and compressions with any of the graphs on your colored papers. So here's an example. I could have, let's graph y equals 3 bracket negative 1 over 2x cubed. And so what you would have to do, first of all, is say, okay, this is related to one of my colored papers. Which graph is it? Well, it's probably not a square root graph. It's probably an x cubed graph. And so off to the side, you'll first go, what does my x cubed graph look like again? So I quickly draw a sketch of my x cubed graph. I know that it looks like this. And I know that these were the 3 important points on that x cubed graph. Then I have to look at the original equation and say, okay, well, as opposed to the regular x cubed graph, I have a 3 here, I have a negative 1/2 here. What are these things? Which ones are horizontal, which ones are vertical? So again, if something is outside the function, that's going to be vertical. How do we tell if something is outside the function for an x cubed graph? Well, the x cubed graph is cubing the x. So now we have to see, what does that little 3, the cube, what does it affect? Is this 3 in front getting cubed at all? No. So that would be considered outside. That's going to be a vertical stretch. We know that we have to multiply our y values by 3. Does this negative 1/2 get affected by the cubed? Yes, it does. So this will be horizontal. The negative will be a horizontal reflection. The 1/2 will be a horizontal stretch. You'd have to multiply your x values by -2. So from my green graph, what are these 3 points? They're -1, -1, 0, 0, and 1, 1. Where do they go? Well, I need to multiply my x values by -2 and my y values by 3. Maybe I'll do my x values first. -1 times -2, positive 2. 0 times anything, 0. 1 times -2, -2. And my y values by 3, -3, still be 0. This will be positive 3. And I've got my 3 new points. So then on a new graph, I often find that when you could graph it on the same one, but things get really busy and sometimes awkward, so it's just easier to draw it on a new graph. I'll take my points. So 2, -3. 2, -3 would be down there. 0, 0 would be there. And -2, 3 would be there. And I draw my graph. Technically on a test I'd lose a 1/2 mark on this one, because even though I drew my graph perfect, I didn't provide a scale. Your brain naturally counts by 1s, but it could be going by 2s or 4s or 6s, so we need to label a couple of points on here so that the scale is provided. So you know what each of your little dash marks or ticking marks count for your x coordinates or your y coordinates. So you could either label points or you could label your axes to get that graph. So I wanted to do one graph where you had to use your colored papers to remember your original and then graph your new one.